Hey there! So you know already how to create your feature branch in Git. You know how to push your changes to the remote repository. You know how to merge branches. Great! But how do you actually get changes made by others from the remote repository to your local one? For example, when you are working in a team and your colleagues made some changes, how do you download them? And that's the topic for today, so let's get started. Alright, so today let's talk about getting those changes from remote repository to your local Git environment. And I will cover two scenarios today. So the first one would be as follows. So this is scenario 1. Scenario 1. And why don't I see it? Oh, there it is. So scenario 1, it would be as follows. So we will have those two users, user 1 and user 2. Both of them will be working on the same Git project. And in our Git repository, we would have the main branch or master, I don't remember how it was called. That contains some changes, some state, right? Then the first user would like to start working on some features, on some bug fixes or new stuff. So this person would create a feature branch, as we did previously. And he would make some changes in this branch, and once he is happy with all the stuff he did, he would create a pull request from his feature branch to the main branch to merge them. And, well, I will approve this, so those changes would be merged. Great. And exactly that's what we did in one of previous episodes. That was user 1. But we also have the second user, user 2, who cloned the repository before the first user started work on the feature branch. So the second user is not aware, or its Git environment is not aware of any changes made by the second user. And this second user would like to see this state. He would like to see all the changes that were merged by the first user and how to do this. And that's the first scenario. So the setup is as follows. So I have our solution A project that right now has a single branch, master. I removed all the other branches just to have a simpler environment. What I also did was to completely remove Git directories from user 1 and user 2 laptops, virtual machines, again, to have a clean environment. So essentially, what we have right now is as follows. So let me draw it. So we've got Azure DevOps repository. It is here. And it has some state, some commits made. And let's say that our initial state is this C1. And I will use those circles, those dots, to represent commits. And at this moment in time, that's exactly what our main branch shows. So let's label our C1 commit with this main branch. And that's exactly what branch is. Branch is simply a pointer to a specific commit. So in this case, it means that our main or master branch simply contains all the stuff up to commit 1. Then we have user 1 local Git environment. So user 1 local repository. And this user, what he did was to clone Git repository from Azure DevOps. So again, he would have the same state as is available at the clone time in the remote repo, which simply means that you would have this C1 commit only, right? Nothing more. And it was achieved by simply using a clone command. Something that we did previously. And in user1 local environment, again, this commit1, oops, let me use a different color. The main branch would point to commit1, exactly as it is in the remote repository. And the same situation would be also in case of user2, local Git environment. So let's add it to the diagram. So we've got user2, local repo, and this user also cloned the repository from Azure DevOps, so he would have the same situation. He would have this commit1 that is considered a main branch, and we achieved this by cloning the repository. So we got clone. So that's the initial state. When all three environments, user1, user2, and remote repository, are perfectly synchronized. They don't differ in any way. Cool. So let's move on. So what I would like to do now is to create a feature branch by this user1, because he wants to start working on some changes. So let's do this. And there are various ways we can create a feature branch. Let's start with going to the virtual machine of user1. That's what you can see right now. And let's create a new feature branch in Visual Studio Code. So that's the Visual Studio Code of user1. And we know already how to create a branch. So let's go to source control and let's create a new branch from our master branch. And let's call it feature scenario 1. Cool. So what we did, we just created a new branch. So let's mark this on our diagram. What changed? So we did this in user1 local repository, and we created a new branch that was called feature scenario 1. And because it was created from main, it basically contains the same stuff that main. So scenario 1. It means that both main branch and scenario 1 branch, both of them point to the same commit, which basically means that they are the same. Cool. Now, we would like to make some changes in our scenario 1 branch. So let's go back to user1 environment and let's make some change. So let's say I would add a new file. Let's call it scenario1.txt. This is the code added by user1 as a part of scenario 1. Cool. Let me save this and let me commit this change. Let's save it in a local Git repository of user1. And again, we know how to do this. Let me add some commit message that describes the change I did. So user1 scenario 1, and let me commit it to the repository. Not push to the remote one, just commit it locally. Let's do this. Yes, please. Alright, so what we did? Let's draw it on a diagram. So we are here in user1 local repository, and we made a change and we committed it. So we know that we have a new commit. Let's call it C2. That points to the previous commit in the tree, to the C1. And because we did this in scope of scenario 1 branch, it simply means that right now, oh come on, let me move it. It simply means that scenario 1 branch now points to commit to C2, right? So in user1 local repository, main branch differs from scenario 1 branch. But that's expected, right? Please also note that at this moment, no one else, apart from user 1, is aware of this scenario 1 branch and this commit, because we didn't push them to the remote repository. So let's say that actually we would like to make those changes available in our remote repository. And actually we can verify in Azure DevOps by refreshing the branches that right now in remote repo, you've got only master branch. There is no scenario 1 branch yet because we didn't push it. So let's do this. So again, let's go to user 1 environment and let's push those changes. Actually, by using this publish branch button. Or we could use push. Yeah, it would result in the same thing. And please note that again, Git detected that, hey, this feature branch scenario 1 has no remote branch. So it simply means that in remote repository, there is no branch linked with this one. And the Git is kind enough to ask us if you would like to create it. Yes, please. So let's do this. So at this moment, we created a branch in a remote repository and we pushed our local changes to this branch. And we should see it here. Yep, we've got new scenario 1 branch available in remote repo. So what we did, so previously this was a commit to create this C2. And what we did then was to push those changes to the remote branch. So simply it means that our commit to C2 was, well, pushed to the remote branch. So we did push. And of course, Git knows that C1 is a parent of C2. So at this moment, those changes are available in both repositories, in user 1 local Git and in remote repo. Cool. Let's say that we would like to merge those changes from scenario 1. Actually, let me tag this, that this is scenario 1 branch. We would like to merge changes from scenario 1 branch to main branch, just to finalize our development process. And again, that's something we did previously. So let's create a pull request. So let's jump to user 1 environment to Azure DevOps, and let's create a pull request. Again, something that we did previously. So I hope you remember how to do this. And yes, we want to merge our feature scenario 1 branch into master. Yes, please, let's create this feature branch. Now, the pull request approver, which is me, Piotr, in this case, would have to approve this. So let me jump to pull requests and let me approve it. Of course, in real life, I would verify if everything is fine, but just to keep it simple, let's say that it is. Let's approve it and let's complete this merge. All right. So what happened? Let's update our Git history on a diagram. So basically, by creating and merging the stuff in our remote repository, we were able to merge scenario 1 changes into main branch. And it resulted in creating a new merge commit, C3. That was actually, it had two parents. Target branch, which is main, and source branch, which is scenario. And what it also did, it updated the main branch. So let me move the tag here to indicate that at this moment, this is our main branch. It contains all the changes up to commit free. So all the changes were incorporated in it. So that's our state. Cool. Now what? Now let's get back to user 2, to the second user, who would like to see those changes from main, this C3 commit, right? So let's jump to his environment, to his local environment, to Visual Studio Code, and let's take a look at the branches he can see, right? Let's check out to master. And does this person see the new file? Nope. And just to remind you, how was the file called that we created? It was scenario1.txt. That's the file that we created as user1 and then merged into master branch. So let's go back to user2 environment. This person doesn't see those changes yet. Why? Because at the time he cloned this repository, those changes didn't exist yet in the remote repo. So there is no way his local environment would see them. So how to do this? How to pull those changes? So what we want to do right now is as follows. We want to get those changes to user to local environment. And actually, there are two commands we can use. Let's start with the first one, which is fetch. Fetching stuff from remote repository simply means I want to make aware my local Git repository of all changes that happened on the remote repo. So my local environment would know how the remote repository looks like. And the very important thing about fetch operation is that it is completely safe. It will not make any changes to your local version of the code. It will not update your code. It will not cause any conflicts. It will not cause any issues. Why? Because we have to remember about those two things in a Git environment. Your working directory and the stuff that Git handles on its own, where it stores the state of the whole Git environment. So I believe it will be easier to understand by using an example. And now, to talk about fetch, we have to introduce origin. So let me add yet another branch. So user 2 has this main branch, but he also has, and everyone has, I just didn't mention them previously, something called origin branch. Origin/main. And what does it mean? Well, those origin branches, they simply represent what your local Git environment knows about the remote repository. In other words, it shows you how your Git thinks the local repository looks like. And at the time we cloned the repository, both of them point to C1 because that's how it looked like at the time of the clone. But now we know that some changes were made in the meantime, right, in the remote repository, but this repo of user 2 is not aware of them because those environments are disconnected. So we have to explicitly ask Git, hey, please go to the remote repository and see what has changed since the last time. And that's what fetch command does. So let me go to user 2 environment, to source control, and let's use this fetch command. Bam. And it did something. It grabbed some changes. So on the diagram, let me show what happened. So basically, Git went to remote repo. It realized, hey, there are those two changes that I don't have yet. So I want to download them. So it did this. It had C2 and C3 it knows how the tree looks like, which branch, which commit is a parent of which branch, of which commit, and it updated the origin main branch, right? The pointer, it's updated its knowledge about the main branch from the remote repository. But it updated the origin one. It did not touch your main branch, your local version of the main branch. So your stuff is safe. Those changes are not yet available in your main branch because you just asked Git to see what has changed in the meantime. So if we go back to user to environment, and if we take a look at the source code, we still don't see this new file. But if we take a look at branches that are available, please also note that we right now can see this feature one scenario branch. Why? Because when we fetched the state from the remote repository, Git updated its knowledge about all branches, including this feature one branch, this scenario one branch, sorry, right? I didn't draw them here, but it is available. But the thing is that those changes are not available in your main branch. That's why fetch is safe. All right, but actually I would like to incorporate those changes into main branch. So how do I do this? And again, that's something that we did in the past, right? You know how to grab changes from one branch and merge them to another one. You could do merge operation. Yes, but isn't there a simpler method of doing this? And yes, there is. You can use pull operation. And what pull does is a combination of two operations. First, it fetches the data, like we did previously, and then it merges your branch, the one that you are in, its origin version with your local one. So it would simply incorporate all those changes that were made on the remote repository into your local branch. And this operation, I mean pull, it will make changes, finally. You might get conflicts if you are working on the same file locally and by someone else on the remote repo. But that's how you do this. So let's go back to user to environment and let's pull those changes. So let's pull. And Git did this, and let's take a look at the files. And right now we can see this scenario one file available here, finally. So what we did? So previously, this operation was fetch, right? And then we also do pull. And what pull did essentially was to fetch and merge changes. So as a result, your main branch is in sync with the origin main one. Obviously, if you made some other changes locally on the main branch, those changes would be merged, hopefully without any conflict. And that's the end of scenario one. So it shows you how to pull changes made by someone else to your local Git environment. Cool. So let's move on to the second scenario. That would be a bit different, but a very common one. So we've got scenario 2. And here we would continue working as those two users. And this time they will work on the same feature branch. They work as a team and they would like to work together on some changes. And once the first person commits some changes to the feature branch, the second one would like to see them, would like to grab them. So how to do this? So again, that's our state that we ended with. And the user to environment is synced with remote repo. User 1, actually not. User 1 environment, its main branch is behind, right? It doesn't contain those changes, these C2 and C3 changes. But at this moment, this is fine. So let's create a new feature branch. So I will start with user 1. So let's jump to user 1 environment and let's create a new branch. This time in a remote repository, not locally. So let's call it feature scenario 2 from master branch. Alright, and that's the branch on which both of our users would be working. So let's move to the Visual Studio Code and let's try to check out or to switch to this branch. But you can see that I don't see this scenario 2 branch that we just created. Why? Again, because my local Git environment is not aware of this newly created branch. So what do I have to do to make it aware? I have to fetch, right? So let's fetch the state from remote repo. And now I should see this scenario 2 branch. Cool. So let's check out to this branch. And yes, we are in scenario 2 branch. So we can draw this as follows. So what we did, we created scenario 2 branch. All right, it was done in remote repository. It was created from main, so it contains this C3 commit. Then what we did was to fetch the changes on user 1 local environment, which essentially created this scenario 2 and main, all the stuff that happened on the remote repo. So we would have this C3. It would be aware of this one. Obviously, origin main would be updated to reflect the state of the remote repo. You would have this origin scenario 2 branch created, and obviously scenario 2 as well. So all of those 3 branches would point to this C3 commit. Cool. So as user 1, let's create some change in our scenario 2 branch. So let's jump to its environment. We are in scenario 2 branch and let's create a new file. So scenario 2 takes the file. This is a code created by user 1 as a part of scenario 2. Let me save this and let me commit and push this change to the remote repository. So I'm doing 2 things at the same time. So user 1 scenario 2 commit and push. Yes, please. All right. And let's mark this on our diagram. What we did. So we created a new commit, C4 from C3. And because we were working in the context of scenario 2 branch, it moved. So scenario 2 branch now points to C4. We also pushed those changes from our scenario 2 branch to Git to remote repository. So remote repo is available, is aware of those changes, right? And obviously its branch also was updated. And we did this as a commit and then push. So if I jump to remote repository and show you in a browser that scenario 2 branch exists, and it should contain those C4 changes, hopefully, if we didn't mess anything. So let me refresh this. We should see scenario 2 branch, and it should contain this scenario 2 txt file. Great, cool. So right now, what do I want to do? I would like to user 2 continue working on our scenario 2 branch, right? But right now, he doesn't have this scenario 2 branch available in his local environment. So he has to pull it, then make some changes, and then send it back to the remote repo, so user 1, his colleague, would see it. So how to do this? So let's jump to user 2 environment. This is it. This is the environment. We know already that to make this new branch visible in Git, in Visual Studio Code, we have to fetch. Because right now, we don't see this scenario 2. It doesn't exist here. So let's fetch those changes. Let's fetch the state from the remote repo to our local environment. So what we did? Again, we fetched. And the only change that we see, it was this commit number 4. And it was done as a part of fetch operation. So this was fetch. And what changed was also that labels changed. I mean, what we have right now is that origin scenario 2 points to C4, right? Now I would like to check out to this branch to start working on this. So let's jump to user 2 environment and let's check out to scenario 2 branch that right now I can see. So again, check out to scenario 2 branch, and please note that yes, I'm right now in the context of our scenario 2 branch. So what I did essentially by using a checkout, I created a local version of the scenario 2 branch. So scenario 2 branch was created, and we are working in the context of this branch. Cool. So let's move on. Let's make some change in this branch and let's push it to the remote repository. So let's jump to user 2 environment, to the scenario 2 file, and let's make some change. Another change made by user 2. Let me save this and let's push. Let me commit this and push to the remote repo. So user 2 scenario 2. Commit and push. Yes, please. So what we did? I know it's getting more and more complex, but that's a typical workflow and it should be quite natural to you, hopefully soon. So what we did, or what user 1 did, was to create a new branch, new commit, C5. So it was a commit. As a result, the state of our scenario 2 branch was updated. So scenario 2 branch now contains those changes, including C5. And we also pushed it to the remote repository. So this C5 is now available in remote repo. And obviously the branch was updated as well. So it means that if user 1, this one, would like to see this change, what does it have to do? Well, it only needs to pull those changes. It doesn't have to fetch, because he already contains those scenario 2 branch. So he also have to pull it. So let's do this. Let's jump to user 1 environment. Let's verify that he doesn't see those changes made by the other user. But if we pull it, if we pull the changes, he should see them. And yes, those changes were pulled and merged into his branch, so he can see the stuff made by the other user. So again, what happened? So we've got C5 commit available in his local repository. That was done as a part of pull operation. And we know that his branch scenario 2, his local scenario 2 branch, now contains all those changes. Right? And that's it. That's how you would work in case of multiple developers working on the same feature. We can also go back to our diagram, to the table that I created in one of previous episodes that showed you various operations. So let's add those two things that we learned about today. So when you do push operation, when you do fetch operation, you go to remote repository and get those changes to your local repository. So that's what fetch does. It updates your .git hidden directory, but it doesn't update your working directory. If you would like to merge those changes, you can do this manually by using merge. Nothing difficult here. But to avoid those double operations, fetch and merge, we can achieve the same thing by using pull. And pull is simply a combination of fetch followed by merge. And basically that's it. So to summarize, in case of working with Git scenarios, the most common workflow is as follows. When you start working with Git, you clone the repository, right? Just to make it available in your local environment. Then usually you create your feature branch in scope of which you make some changes, you commit them. If you would like to push those changes to the remote repo, so they are not available only on your local machine, you would, well, push them, right? So they are available in the remote repo, like in Azure DevOps. If you would like to then grab changes from the remote repo and update your local environment, then you could use fetch and pull. And the difference is that, well, fetch updates only the knowledge about the remote repo. It doesn't modify your working directory. It doesn't modify your code. Pull, on the other hand, it fetches the code and it merges them. So it updates your code. And that's it. So that's a very typical flow. And in most cases, those are the only Git commands that you'll use. Maybe apart from some related to reverting stuff. But if you familiarize with those, you should be good with working with Git. And that's it for today. Thanks for watching and see you next time. Take care.